Hi, it's Rory again, here to do some more simulation. DC drop analysis is a very common power integrity check to run. We will do multiple DC drop simulations over the life of the PCB. The earliest you would want to run a DC drop analysis is after the power planes have been created in the layout, and after the critical ICs, fanout, and breakouts are routed. In our case, this is the DDR4 DRAM's fanout. There's no reason to run DC drop on ideal planes and structures, so we wait until some of the layout is completed, which Rilfred and Zach have already done so. This type of power integrity check is important because fanout vias might perforate the plane and affect the power delivery. I will run a DC drop simulation on the P1V2 net because this is the power plane used for the DDR4 DRAMs. Running the analysis, I can see that I passed the max voltage drop and max via current, but have failed the max current density check. Bringing up the power scope and HyperLynx, I can manipulate the view to see 3D, 2D, and many other options to look at the DC drop voltage, which is turned on by default. I want to take a look at the current density because that is where the HTML report is saying we have a failure. By isolating the layers here, turning them off one by one, I see that the issue is on the bottom side. The thermal ties are too small in this area and need to be adjusted by the PCB designer. The thermal tie size needs to be increased. This is a very common issue here and it's easy to fix, so as far as finding problems with simulation, this is one of the easier ones to correct. This will have minimal impact on the layout designers now, but will have been a problem with the PCB after fabrication if we didn't catch it. I will send this recommendation to the PCB designer to fix these thermal ties. So going back to our report, the voltage drop is fine. We're passing the checks here for the voltage drop. Checks for the via current also look good. And the only issue we have is a current density issue, but we've isolated that to some thermal ties on the bottom layer, and we will have the PCB designer fix those. Once the rest of the board layout is complete, I will run a final DC drop simulation on the entire completed PCB as a final sign off to make sure we didn't miss anything once the board is fully populated.